7S power might be the best upgrade you can make for your 1/8 scale bashers. Today, I'm gonna tell you why, and I'm gonna show you how. Making it all possible are these beautiful new 7S batteries from SMC and this beast of a 1 kilowatt charger from Genzace. Not only is this charger gonna allow us to charge 7S batteries, but it's gonna allow us to charge these big, beefy 4S batteries faster than we ever have been able to before. Before we get into this upgrade, we need to see how this truck performs with the stock power system, so let's go see how fast it is. We're usually wheelie limited on short wheelbase trucks like this, but let's see what we can get out of it on 6S stock power. This truck is a little bit heavier than it is stock, so I've got quite a few upgrades on it, but as you can see, it's still pretty quick. It's also surprisingly stable for what it is. Let's give it one more pass. Okay, let's see what we got out of it. I'm gonna go ahead and bring it in. Still fun though. And we got 50 miles an hour out of it, which is pretty good. And as you can see, this thing still has plenty of power for off-road running. It is a lot of fun, pretty wild, and this is probably my favorite truck you can buy right now. This thing is an absolute blast, and for stunting, it's really hard to beat. But how is running 7S going to allow us to do that? To answer that question, we need to go over some basics. The amount of power an electric RC car has is limited by 3 basic things: your motor, your ESC, and your battery. Obviously, your battery is what provides the energy to the system. Your ESC controls how that energy is fed to the motor, and the motor is the ultimate, or should be the ultimate, limiting factor in the system based on how much energy it can actually use to convert electricity into physical motion. The unit of measure for that energy we typically use in these systems is the watt. 1 watt is a joule of force over 1 second, but that part's not really that important. What is important is the wattage is calculated by multiplying the voltage times the current. The voltage is of course in volts, and the current is measured in amps. So let's say this motor has the ability to convert 1000 watts of electrical energy into mechanical motion. Obviously, the spinning of the rotor and the spinning of the output shaft. Now let's say for the sake of simplicity that this battery is 10 volts and this battery is 100 volts. That means to get the same 1000 watts of power to the motor, you would need 100 amps coming out of this and only 10 amps coming out of this. And this is where the magic happens with higher voltage. The higher the current you're working with, the thicker the wire you need. That's because, and this may seem a little counterintuitive, no matter how much actual power is going to your devices, the wires themselves are only sized based on current carrying capability, not on voltage. For instance, this 10 AWG wire can handle around 150 amps, while this 14 AWG wire can only handle about 50 amps. Because of the way the actual energy is calculated, if you run 3 times the voltage, you can get the same amount of actual power through this wire as you can with this wire at 1/3 the voltage. This advantage doesn't just apply to wiring either. The higher the voltage, the smaller all of the electronics and components have to be to get the same amount of power. And that's where things really get interesting in RC bashing. Because while typically we associate higher voltages with larger components, it doesn't actually have to be that way. You can use the advantages we talked about to run smaller components at higher voltages and save weight for the same amount of power. By the way, if you like this awesome front shock tower, make sure you check out my last video where I talked about CNC machining. It was really, really cool. More power and less weight is what we're going to be doing in this video. Higher voltages will actually allow you to get the same amount of power out of smaller motors. Of course, there are some caveats to this, which we'll talk about in a few minutes. Previously, running 7S has been a real challenge, and that's primarily been because of charging. Running 8S and things like the X-Max and XRT has been fairly straightforward because we just ran 2 4S batteries. But to run 7S, you'd either have to run a 5 and a 2 or a 4 and a 3, and that gets really weird. And that's where the new Genzace IMARS D1000 comes in. Not only is this a 1000 watt AC powered battery charger, but it also does 7S. Of course, there previously have been other options for charging 7S, but they've typically been very expensive and very clunky, requiring external power supplies to run. This thing's got a power supply built into it. Speaking of which, let's take a look inside. Of course, I want to stress that you really don't want to be taking your battery charger apart. Unless you know what you're doing, there are high voltage components in here that can hold a charge, and if you're not careful, you could kill yourself. That's why I'm going to do this, so you don't have to. By the way, have you ever wondered why your old plastic screwdriver handles stink? I got this old Craftsman screwdriver from my dad, and it's been around a long time, and it really does not smell good. This is actually a pretty common problem for a lot of old tools, and it's because these handles are made out of something called cellulose acetate butyrate, and when that CAB breaks down, it releases something called butonic acid. And butonic acid, also known as butyric acid, is what makes vomit stink. So the next time you grab an old Craftsman screwdriver and you think it smells like puke, you're not going crazy, it actually does. All right, with those 4 screws removed, this base isn't just flying off. I don't think there's one here in the middle. There's a bit of a depression underneath the sticker, but I think that's just an injection molding mark. I think I'm gonna have to remove this off camera so I don't damage anything. Okay, there we go. It pops apart. It was just really tight, but we do have some wires holding us up here. Got one little connection right here. This is an XT30, which is interesting to see. Another connection here. And then the wires that go to the input. These wires are identical, and being AC input, it probably doesn't matter, but I'm gonna go ahead and mark one of them anyway, just so I put them back where they belong. I was really struggling to get those connectors off, and that's actually a good thing because these are positively retained. Typically, these types of connectors just push on and rely on friction to hold them on, but these have little tabs, and without pushing those tabs, you can't remove them. This is a great feature to see on a mains wire. This bottom section houses the power supply, and it's pretty heavy, and it's also a really interesting architecture. As you can see here, what we actually have is 2 fully independent power supplies. The input goes into this one and then jumpers over to this one, and they're just inverted from each other, but these 2 pieces here are identical, and it appears as though each one of them is going to feed a separate channel on the actual charger board. We're not going to dig too deep into this because I'm not an electronics expert, but I do have a few things I can look for. As you can see, we have Celastic holding down various components. That's to reduce issues from vibration. These copper chokes appear to be high quality. We've got a big beefy capacitor hiding in there. Again, I want to warn you that these capacitors can hold a charge. So even if you have something like this unplugged, you can still get shocked from it. If it's designed correctly, it shouldn't do that, but it definitely can. We've got a big integrated circuit back here. And then along the middle on both sides, we have what I'm assuming are MOSFETs. Those are going to be the main devices that deliver power from the power supply to the actual charging system. And that's why they've got these big heat sinks on them. If you don't know much about electronics, one way you can get a good feel for the quality is by looking at the brand on the capacitors. These are Acon brand, and this is not something I've ever heard of before. I did a quick search, and these appear to be fairly low-tier capacitors. If these capacitors were Nichicon or possibly Rubicon, Sanyo, Panasonic, Hitachi, those kinds of brands, that would be a first-tier capacitor, and it'd be a really good sign for the quality of this. I will say, though, that at least these are branded, and Acon does have a website, which means these are probably at least reasonable quality. If you see completely unbranded capacitors, that's when you really need to start to worry. The other thing I find really interesting on this board is the use of XT30 connectors as interconnects between the power supply and the main board. The entire system's only rated at 25 amps, so these XT30s should be fine, even though they feel a little small. One nice thing is, though, these are genuine AMAS connectors, which means they're going to be high quality. Moving on to the actual brains of the charger, this board looks to be pretty well made. It's using a 32-bit gigadevice ARM processor, and overall seems to be made just fine within my limitations of understanding of how these things should look. This does have a 70mm cooling fan on it with only 2 wires coming from it, so I suspect this isn't going to be speed controlled. Hopefully it turns on and off when charging and just doesn't stay on all the time. Speaking of which, let's go ahead and get this thing put back together and see how it works. By the way, when screwing these self-tapper screws in, always make sure you back the screw up before you start screwing it in until you feel it click. That means it's fallen into the threads it's already made before. If you don't do that, you're going to be cutting new threads each time, and you'll end up stripping out the threads eventually. Of course, on something like this that you're not going to take apart very often, it's probably not a problem, but it is a good habit to get into. Before we start charging batteries, we need to get the ESC installed, and this is going to bring us to one of the main technological problems with running higher voltage, and that's the lack of availability of hardware. This is a Mama Monster 8X, and it's one of the few ESCs I'm aware of that can run 7S that will actually fit in a platform like this. We're going to be installing this with double-sided tape, so I'm just going to clean the surface of the ESC and the surface I'm taping to, and then we're going to apply some real 3M VHB. Fortunately, the lack of hardware really isn't any kind of technological limitation. It's primarily just that no one's making the hardware, and to fix that, the demand for that hardware just needs to increase, and then they'll start making it. We're just going to go ahead and stick this down. A lot of people ask me how I get these ESCs to stay stuck with double-sided tape. The trick is to use a good quality, genuine VM3HB. Make sure both surfaces are completely clean. I use rubbing alcohol on a paper towel to clean them. Stick it down and then give it overnight to set up. These kinds of pressure adhesives don't come up to full strength right away. And if you just install this and then immediately go bash it, it's probably gonna come undone. Give it overnight and it won't. I'm gonna go ahead and finish getting this wired up off camera because I'm really excited to show you what that charger has to offer. There's some pretty neat features. Let's check it out. So what exactly makes this charger so special? Well, first of all, as I said, it does up to 7S batteries, which is pretty rare. It uses XT90s for its connectors, which I think is really, really nice. It does come with adapters for EC5, XT60, and DINs. This should cover most batteries you're gonna be charging. It has a power button, which is actually pretty rare. But to explain its best feature, we need to talk about watts again. A lot of chargers advertise being 15, 20, 25 amps, and that's great, but it's the wattage output capability of the charger that really matters. And a lot of chargers can only output 100 or 200 watts total. That's really limiting. Let's take this 4S 5800 milliamp hour battery, for example. 5800 milliamp hours is 5.8 amp hours. That's the capacity of the battery. And that means to charge this at 1C, or 1 times its capacity, you're gonna be charging it at 5.8 amps. This is a 4S battery at 16.8 volts, and as we said earlier, watts is amps times volts. So to charge this battery at 1C, you're gonna need about 100 watts. If you've got a 2-channel charger that's only 200 watts, this is gonna be the limit of what you can charge at 1C. Anything less, and you're charging at less than 1C. And then if you're getting into bigger batteries, things get much, much worse. This thing does a true 1,000 watts across both channels, and it does it without needing an external power supply. Another huge limitation of smaller chargers is their discharge capacity. Now you might say, I don't discharge my batteries, but you probably do. If you go to storage charge your battery and it's above that storage voltage, you're gonna be discharging down to that storage voltage. The vast majority of chargers out there only discharge at around 10 watts. And that's because when they're discharging, they're actually just using some resistors in here and bleeding that power off as heat. This thing can discharge at a full 140 watts across both channels. Now, I'm not sure what it can do across just one channel. Let's find out. To do that, we're just gonna select the channel, go into the settings, choose discharge. I'm gonna crank that current all the way up, and let's see what it can do. Okay, so it's settled in at 6.5 amps, 3.7 volts per cell. That's 96 watts, or near enough to 100 watts single channel. That's 10 times the discharge capability that most chargers have, and that's really, really nice. That means if you're discharging down to storage charge, you're looking at minutes instead of hours. Now, the last party trick that this has is full smart capability. If you're using one of the G-Tech batteries from Gensace, you can tell you are if it has this extra little pin on the balance connector. It's going to automatically detect the settings and automatically start charging for you. Now, the last thing I want to check is whether or not the fan actually turns off when you stop charging. Some chargers don't do that. Let's find out. Okay, so it doesn't turn on right away. And it does turn off when you stop charging. That's really, really nice. This fan is pretty loud, but you won't have to listen to it all the time, only when it's charging above a certain current. So this thing seems like a really awesome charger. It's got a ton of cool features, but now let's get this 7S battery charged up and see what it can do in the V6 Notorious. Then when we come back, I'm gonna talk about some of the disadvantages of this setup because it's not all sunshine and roses, but for now, let's go bash. Okay guys, we had 50 miles an hour on 6S. Let's see what we can do on 7S. Oh, God, she's got more power, that's for sure. Okay, let's see if we can do this without wheeling out. Yeah, I think we're still gonna be wheelie limited here. She definitely has more power though. Give her another pass. Oh, she's wheeling. All right, let's see if we can get one real good clean run out of it. No, hang on, one more try. She's pretty hard to control with this much power. All right, here we go. Oh! Okay, I'm gonna give it one more pass. We can get this clean. There it is! Alright, let's see what we got. Okay, 57 miles an hour. That is a really nice improvement, and we could go faster if it wasn't wheeling the whole time. Let's see how this thing bashes on 7S. as I hope you guys can tell, this thing was definitely more powerful on 7S than it was on 6S. We're only talking about 15% or so more power, but remember, we're getting that with 0 extra weight. One thing we haven't talked about yet is safety with these higher voltage batteries, and it's not really something you need to worry about. These aren't a shock hazard at 7S and even 8S. Typically, anything below 50 volts is considered safe for human skin, and that's because our skin has a high enough resistance that it just doesn't matter. As you can see, I've got this connector plugged into this 7S battery. It's fully charged. I'm touching it and I feel absolutely nothing, not a tingle, nothing. Now, if your finger were wet, you might feel it, but it's still not going to be dangerous. Now, speaking of things that are safe to do, make sure you hit that bell to turn on post notifications. I've got 2 giveaways going right now that you might not even know about. And if you do know about them, if you don't have post notifications turned on, you might not find out about the results because I put them in a community post. The last thing we need to talk about are these beastly batteries for the Traxxas XRT. If you want extended runtime, you're going to be running big batteries like this, and charging these can be a real challenge for smaller chargers. At 1C, these 11.4 amp hour batteries can take almost 200 watts each, and the vast majority of chargers out there are only 200 watts or less, which means if you want to run these big beasts, you're probably going to be charging them at half of their minimum rated current. But that's just the minimum. These things are rated to be charged up to 5C, or 5 times their capacity in current. Even large chargers like the Hoda S6 can't even come close to that, but this charger can. Of course, this charger's not going to be able to do a full 5C on both batteries at the same time, but let's find out what it can do. It is important to mention that if you charge your batteries really fast, you're going to be getting a little bit less capacity in that charge cycle, and overall you're going to get a reduced lifespan of the battery, so it's not the best idea to do it all the time. But let's see what this thing's capable of. Both of these are starting at storage voltage, and I'm going to run them at the full current that this thing will allow. Let's see what we get. Okay guys, that was amazing. We were getting a full 25 amps per channel. I thought this thing could only do 25 amps total, but apparently it can do 50 amps total. That means you could charge both these batteries up from storage voltage in less than 15 minutes. I'm gonna go ahead and do just that, and then let's see how long these things last in the Traxxas XRT. Man, that extra runtime really felt good. Of course, we added more weight to the vehicle with those larger batteries, but if you want more runtime, having bigger batteries and a big charger to charge them is really, really nice. Now, that being said, why aren't more people running higher voltages in their vehicles? The biggest problem is availability and cost, and those two problems are kind of intertwined. Right now, there isn't a huge demand for 7S systems, so the batteries we can get, even though this is a really nice one, aren't perfect for bashing. This doesn't have the G10 plates on it, and isn't exactly the right size for most bashing vehicles. These 7S batteries are also more expensive, as are the ESCs to run them and the chargers to charge them. But this is not a technological problem, this is just a supply and demand problem. Higher voltage systems have basically every advantage over lower voltage systems, and the only reason we're not using them is because we're not using them. I'd love to see manufacturers start putting 7 or even 8S systems in the 6S vehicles we currently run, because we could make them lighter and more powerful. We could even run smaller motors for the same amount of power, as long as we're willing to deal with higher gear reductions, as smaller motors would need to spin faster to make the same amount of power. That being said, the technology is there, we just need to start using it. Speaking of things we need to do, make sure you get subscribed, hit that bell to get notified of future videos and giveaway results, and then check out one of these videos.